So good morning, good afternoon, good evening. Whatever time it is, I do hope that you are having a good time. This is the 6th lecture, the 7th if you're watching them on YouTube, in a series on critical thinking. So what I would like to do today is to talk to you more about deductive arguments and how they work. So first let's review. So a valid deductive argument is one in which if the premises were to be true, the conclusion would be true. So this is hypothetical. So we're not saying the premises are true, we are saying if the premises were true. So for those of you who are Japanese speakers, this is the kateho. We're not making a claim about facts, we're making a claim about structures. And if something is a valid argument, it has a property called truth-preserving. Truth-preserving means if all of the premises are true, that truth will be preserved and will last until the conclusion. In doing deductive arguments, there are three very important laws that we need to keep track of. The first is the law of non-contradiction, which states that A and not A cannot both be true at the same time. So we can say not A and not A, with parentheses there. The second is the law of the excluded middle. Now this says that for any claim, the claim is either true or it is false. So this guy is blue or this guy is not blue. We can't have claims in the middle. We need to make a choice. Is this claim true or is this claim false? The last that I want to mention today is the law of identity, which is anything needs to be the same throughout. So if I use the term dog, I have to use it with the same meaning through all of my argument. So we also looked at several argument forms, which I hope that you can remember. So the first of these argument forms is modus ponens. So modus ponens has the form if P then Q, P therefore Q. A second argument form, modus tollens. Modus tollens if P then Q, not Q, therefore not P. Disjunctive syllogism, A or B, not A, therefore B. Hypothetical syllogism, if P then Q, if Q then R, therefore if P then R. So finally we have dilemma, and with dilemma there are two forms. A or B, if A then C, if B then D, therefore C or D, or A or B, if A then C, if B then C, therefore C. So there's two things that we can highlight that will help you find these patterns pretty easily. And if we do three, you should always be able to find them. So there's an if-then. Again, in this pattern, if-then. This pattern, if-then, 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 if-then. So what's interesting is disjunctive syllogism has no if. Alright? Now let's highlight all of the nots. Alright, there's a knot here, there's a knot here. So there's three patterns that have no knots. So they're here. So this pattern has if and no knot. These patterns too, if times 3, no knot. This pattern here, 2 if, no knot. This pattern here, 1 if, 2 knots. So if you just look for these patterns, this is another helpful way to be able to find this sort of argument. Okay, on to the next slide. What I want to talk to you about today is logical operators. Operator is a big word. A similar word might be function. An operator is something that does something to something else. Here are the operators that we're going to be working with. The first operator is negation. So negation is basically a big word for not. So I've mentioned that before. So Abe is prime minister. This is true. Abe is not prime minister. This is false. Hokkaido is great. This is true. I love Hokkaido. Hokkaido is not great. This is false. Rice tastes bad. This is false. Rice does not taste bad. This is true. You are a teacher. This is false, I assume. You are not a teacher. This is true. So one thing to remember is that negation works on one claim, or one group of claims. So everything else we look at will be a little bit different, but negation works on a set of one. Alright, conjunction. A conjunction looks at two claims, and if both of those claims are true, a conjunction is true. So if claim 1 is true, and claim 2 is true, it's true. But in the case of a conjunction, there's something interesting. If either of the claims involved in a conjunction are false, the entire conjunction is false. So if we look here, the left claim is true, but the entire conjunction will be false. If we look here, the right claim is true, but the entire conjunction will be false. And again, this looks at two claims at once. So, conjunction is a big word for and. One conjunction is true if both parts of the and are true. Alright, let's look at conjunctions a little bit more. So Abe is Prime Minister. Let's call this A. This is true. Hokkaido is great. Let's call this H. This is true. Rice tastes bad. Let's call that R. And this is false. And you are a teacher. Let's call this T. And this is false. So, Abe and Hokkaido. So we're going to take that and put it here. True and true makes true. Let's see, Abe and rice. This is going to be false because Abe is true, but rice is false. So we have T and we have F. Alright, what about Abe is Prime Minister and you're a teacher? Again, T and F gives us F. Hokkaido and Abe. So we just flip them around. We get T and T. This is true. Hokkaido and rice tastes bad. So this is true. Hokkaido is great. I love Hokkaido. Rice tastes bad is false. So the two together are false. Hokkaido and you are a teacher. Hokkaido is great and you are a teacher. Left part is true. Right part is false. So this is false. Rice tastes bad and you are a teacher. False and false gives us false. So, there's only one claim in this entire set that gives us true, which is when both are true, so A and H. So those together will give us something that's true. Disjunction. Disjunction is a big word for or. Now, a disjunction is true if either of the two claims is true. So, if claim 1 is true and claim 2 is true, it's true. If claim 1 is true or claim 2 is true, it's true. So here we have true gives us true. Here we have one true gives us true. And again, this looks at two claims. So a disjunction will be true if either of the two claims is true or if both claims are true. So we're not looking at it in this class, but there is a different operator. I just want you to know it does exist. That is called exclusive disjunction. Alright, let's look at the same sort of claims, but this time we're doing it with disjunction. So, we have again our claim that Abe is Prime Minister or Hokkaido is great. So we have true or true is true. So Abe is Prime Minister or rice tastes bad. True or false is true. Abe is Prime Minister or you are a teacher. True or false is true. Now Hokkaido is great or Abe is Prime Minister. So we have true or true, and that's true. Hokkaido is great or rice tastes bad. So we have true or false, again true. Hokkaido is great or you are a teacher. True or false, this is true. And rice tastes bad or you are a teacher. This is false and false, which is false. So to put it another way, with a disjunction, if any piece of it is true, the entire disjunction is true. So conditionals are the hardest to understand, and I just want to talk to you about that for a bit. I'll try to explain it in a few different ways. I hope it works. If it doesn't work, please leave a comment on the video or please ask me a question in class. So, if it is raining, the bus is late. So a conditional again is an if-then sentence. So if we want to think about that like our other arguments, what we're going to see is something like this. So this is going to be our left-hand side. Let's say that's R. And this is going to be L for late. So if it is raining, the bus is late. So we're going to call this conditional true in 3 different cases. So one of them is pretty obvious. So if it is both true that it's raining and that the bus is late, we're going to call that true. There's going to be 2 other cases we're calling it true. But first I'll mention the one where we're calling it false. So if it is raining, but the bus is on time, or we could say the bus is not late, then we would say this conditional is false because we tested it and it's raining but the bus still comes on time. But there's 2 more cases where we're going to call it true. So if it is false that it is raining and the bus is late. So not R and L. And again, not R and not L. So let me try to explain why we do this. The reason that we do this is that we never tested whether it is the case that if it were raining, the bus would be late. So when we say if then, we are describing something that we claim is enough for it to happen. We're not saying it's the only way it can happen, but we're claiming we think this is enough for it to happen. Now there are other logics that we're not studying in this class that will deal with this differently. But just for the sake of simplicity, because of the law of the excluded middle, every claim and every statement has to be true or false. So in our case, to make a conditional true or false, we make the choice that it is true when both parts are true, and that it is true when the left-hand part is false. So let me repeat that. We make the claim that it is true if both the left and the right are true, and that it is true if the left is false, even if the right is true or false. So let me give you a few just kind of weird ones, and we'll just talk about it briefly. So thus, the following conditionals are all true. If Hokkaido is part of France, then Tokyo is the capital of Japan. So this has us with something that is false, and this gives us something that is true. Let's switch colors here. So this gives us Hokkaido is part of Japan, then Tokyo is the capital of Japan. This gives us false to true is true, true to true is true. And this strange one. If Hokkaido is a part of France, which is false, Tokyo is not the capital of Japan, which is false. So in this case, false and false gives us true. But we do have one case where it is false. So Hokkaido is a part of Japan. But Tokyo is the capital of Japan. So this is false. So if we have true implies false, that is false. So I know I'm moving quickly. You can slow down the video if you want to. You can watch it multiple times. You can ask me questions in class. Please do. So let's look a little bit more at this sort of thing. So we're going to use the same 4 examples. Abe is prime minister, true. Hokkaido is great, true. Rice tastes bad, false. You are a teacher, false. So again, this looks at 2 claims. And in this case, unlike with conjunction, so our big word for and, or disjunction, our big word for or, the order matters. So let's look at these cases. So if Abe is prime minister, Hokkaido is great. So here we have true and true and true. If Abe is prime minister, then rice tastes bad. So here we have true and false. false. If Abe is prime minister, then you are a teacher. So we have true and false, and this is false. If Hokkaido is great, then Abe is prime minister. So we have true and true. So the entire thing is true. If Hokkaido is great, then rice tastes bad. We have true and false, so that's false. If Hokkaido is great, then you're a teacher. That's true and false is false. But, two more cases. If rice tastes bad, then you are a teacher. So this is false and false. So this is true. Same thing if we reverse it. If you are a teacher, then rice tastes bad. False and false is true. Okay. So just to recap, not is about one claim. The truth of a not A is the opposite of A. So if A is true, not A is false. If A is false, not A is true. And is about two claims. If A and B are both true, A and B together are true. If not, it's false. Or is also about two claims. But if A is true, or if B is true, then A or B, as a set, is true. A conditional is about two claims, and it is true unless the left-hand part, the condition is true, but the consequent is false. So if the right-hand part is false, but the left-hand part is true, it's false. In all other cases, it's true. So if the left-hand part is false, it is true. If the left-hand part is true, and the right-hand part is true, then it is true. Okay. So here's another way to look at that. So if we have negation, if we have P, when P is true, not P is false. When P is false, not P is true. Conjunction, we have P and Q and P and Q. So when P is true and Q is true, P and Q is true. When P is true and Q is false, P and Q is false. When P is false and Q is true, P and Q is false. When P is false and Q is false, P and Q is false. Conditional. P and Q, again, P true, true, false, false, Q true, false, true, false. Then P and Q together are true, false, true, true. Disjunction. P and Q, true, true, false, false, Q true, false, true, false. So then we get true, 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 false. So the name of this particular device is a truth table. This is a way to think about all of the possibilities, whether they are real or not. So this is something we can use as a tool to think about validity. So we want to think about how we can prove validity. Now, validity is interesting. So validity is the following claim. If the premises are true, then the conclusion must be true. So, there's two ways we can think about whether something is valid. So here we have an if-then sentence. If the premises are true, then the conclusion must be true. So what we can do is we can start by making the premises true. So we can think about an argument, and we can just say, well, for the sake of argument, what if we thought all the premises were true? Then we can test. We can see if the conclusion can be false. If this is possible, the argument is not valid. If it is not possible, the argument is valid. So this is kind of abstract, so I want to make it more practical. So I'm going to add a little bit more information about truth tables, and then I'm going to talk to you a little bit more about truth tables, because truth tables are extremely valuable for determining whether arguments are valid. So, a truth table shows what happens for the value of each variable. So I gave you a couple of examples, so I'll just go back for a second. So this is a truth table for negation. We can also do truth tables for arguments. And when we do that, what happens is we look at every possibility for every variable, And it can show every way the premises are true and false, and whether the conclusion is true or false. And through this, we can see whether we have a valid argument. So basically we can see when we have true premises, can we end up with a false conclusion. So again, this is about premises, not variables. And then about the conclusion, whether it's true or false. So this week, I just want to do 2 or 3 of these problems, and then we'll call it a day. So, I want to show you modus ponens and modus tollens. So modus ponens, so we've got the form down. If P then Q, P therefore Q. So, if people are thirsty, then people should drink water. People are thirsty, therefore people should drink water. So, let's look at the second one. If Taku doesn't like to run, he should swim instead. Taku doesn't like to run, so Taku should swim instead. So I've told you this is valid. Now let's see if we can prove that it's valid. Alright, so I'm going to say that the words Taku does not like to run are R. And I'm going to say the words he should swim instead are S. So these are our 2 variables. These are the 2 things we're saying, could this be true or false? So then what we're going to do is we're going to write this way. True, true, false, false. True, false, true, false. So this is going to help us to think about the premises. So the first premise, if Taku does not like to run, he should swim instead. So this is R, implies S. So, if R is true and S is true, R implies S is true. If R is true and S is false, this is false. If R is false and S is true, this is true. If R is false and S is false, this is true. So this is something that was on an earlier slide. So if you don't remember, please feel free to go back a few minutes in the video and then come back. So there's something else that's interesting. So the second premise is the same as R. So we can just copy this row over. So I'm going to do that now. So, true, true, false, false. And our conclusion is the same as S. So I'm going to copy that row over too. So true, false, false. So now let's remember the test for validity. So an argument is valid if it is the case that whenever the premises are true, the conclusion is also true. So I'll repeat that. An argument is valid if it is the case that whenever the premises are true, the conclusion is also true. So, we can test this argument. Alright? So, the premises are both true here. But, the premises are not true here, here, or here. So we have one false premise here, we have one false premise here, we have one false premise here. So, in the place where all the premises are true, is the conclusion true? The answer is yes. So, we have shown that this is a valid deductive argument, because we've shown that the only place where both premises are true, the conclusion is also true. There's no way to make both premises true with the conclusion being false. Okay, on to the next one. So again, validity is the idea that if the premises are true, the conclusion must be true. So we start by making the premises true, and we see if the conclusion can be false. If this is possible, the argument is invalid. If this is not possible, the argument is valid. So let's do modus tollens. So if P then Q, not Q, therefore not P. So, if I am using an umbrella, then it is raining. It is not raining, therefore I'm not using an umbrella. Alternate example, if the yen is weak, the dollar is strong. The dollar is not strong, the yen is not weak. So again, we're going to make a truth table. So I'm going to call using an umbrella U and reigning R. So again, true, true, false, false, true, false, true, false. So again, the law of the excluded middle. Every claim must either be true or false. So with two claims, there's 4 possibilities. So true, 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 false, false, true, false, false. So we've covered every single possibility. So these are our variables. Alright, U implies R. So U is true, R is true, this is true. U is true, R is false, this is false. U is true, U is false, R is true. This is going to be true. U is false, R is false, this is going to be true. So not R. So we can't just copy it over this time. We have to do a negation. So true becomes false, false becomes true, true becomes false, false becomes true. Same thing with U, we need to negate this. So now we have false, false, true, true. Alright? So where are both premises true? So not this row, not this row, not this row. Just this row. So again, we end up with 2 true premises and a true conclusion. So we have shown that for modus tollens, there is no possibility where there's 2 true premises and a false conclusion. So this is how we prove validity using a truth table. So again, validity is if premises are true, then the conclusion must be true. So we start by making the premises true, we see if the conclusion can be false. If this is possible, then the argument is invalid. So just a bonus question. Think about the definition of validity and think if there's another way. So next week we're going to do a little bit of practice with that other way. So thank you for your time and your attention. I hope these videos are useful if you're watching them on YouTube, whether you're in the class or you're not in the class. Please feel free to comment, to ask questions, to interact with me, to tell me what I'm doing wrong or what I'm doing right. I look forward to hearing from you, and greetings from Hokkaido, Japan.